In this video, we're going to start writing our very own command processor that the game will use to process commands the user enters. So you'll see if I type go, it'll say go where, and if I say go east, we go east. And if I type an invalid command like hi, we get an unrecognized command. You'll also learn how to add this nice starting message here that will kind of orient your player and tell them what's available to them and kind of give them a way to play the game, a little bit of instructions right when they start. So let's get started. Alright, so the first thing that we need to do in order to add a command processor to our game is come into our game script, and we're actually going to add a new node that's going to be solely responsible for processing these commands. But let's do a little bit of refactoring first. So if we look at our game script here, we'll see that we're pretty much doing all of our input handling within the onInputTextEntered function, which gets called whenever our text gets entered. It's a signal that we've connected to our input area. So there's a couple things we need to do. First, I kind of want to make let's really lean into the single responsibility principle here and kind of modulate some of the functionality that we're doing in this function out to a different one. So for example, deleting our history, that should really be its own function. I think it can still live within this game script because it's kind of handling the game as a whole, for now at least, but let's move it into its own function. So I'm going to create a new function here, and I'll say function delete history beyond limit. And you can call it whatever you want. I'm just trying to give it a name that is clear. I mean, it clearly indicates it's not just deleting history, all history, but you can clearly see when you look at this function, oh, it's going to delete the history beyond our limit. And so giving your function a name that just kind of makes sense and indicates exactly what it's going to do is a helpful thing to do. So let's grab this. I'm going to hit Command X to cut and come over here and just paste it in. And I'll have to Shift Tab that. And we should be good to go. Okay, so now we've moved out our delete history beyond limit function, and then I can call it within here. So delete history beyond limit. So I haven't really changed anything. We've just kind of made our function a little bit easier to read. All this logic can just live out here. And if we ever need to delete history at another part in our code, we can just call this function now. It's not living within this input text entered function itself. So we've got that. That's really good. Now what we need to do is actually start writing our command processor. So whenever text is entered by the player, this function is going to get called, and we're going to get an input response instance, and then we're just setting the text to be this random response here. So I think, at least for now, it's totally fine for us to keep this input response creation within our game script, but what we really want is to create a dedicated command processor node that's going to be able to do all the things that we need to process commands internally there, and then it can give us a response back to our game based on whatever the current state of the game is, etc. So in order to do this, I'm going to come to our game in the scene tree, and I'm going to hit the plus button or Command A, and I'm just going to add a node, not a node 2D, not a control, a spatial, just a regular node, because we don't really need this to have any other properties. It doesn't need to have any UI properties. It's not a container. And it doesn't need to have any 2D location. It's just a node that's going to exist with a script. And so I'm going to change this to be command processor. Call it that. I'm going to attach a script to it. And we'll just keep the default name, command processor. And so here we are going to need to pass in and process all of our commands. Now, if you're familiar with text parsing and old retro text adventures, there's a variety of different text parsers that have been used in games throughout the years. There's the really famous Infocom and some other companies like that that made text adventures that had these really amazing text parsing engines, but they're pretty complicated. We're not going to get to them, at least not yet, if ever. What we can do is a very simple, and it's a classic style, just the 2-word command prompt. So every command consists of 2 things, a action word and then the object of that action. So if the command is go, a second word would be west or north or up or down. Or if it was take as the command, the action would be take apple or take key, something like that. So it's a really simple time-honored system that works. And that's what we're going to start off with because it's easy to do and it'll get us pretty much everywhere we need to go in our game. So what we are going to do is have a function. We'll say function process command. And here we're going to have 2 parameters. One is going to be first word, and this is going to be a string. And the next is going to be, you guessed it, second word. This is also going to be a string. So we've got this. This is our process command function. It's going to take both of these things and then it's going to do something with it, which we'll get to in a second. First, we need to actually wire this up to our game script. So what I'm going to do in order to get a reference to our command processor node, which I've just dragged to the top of our scene up here, it doesn't really matter where it is, but I'm just going to say, I'll throw it up here on line 10, on ready var, and we'll say command processor, and this is just going to be $command processor. That easy. And so now we've got a reference to our command processor within our game script, and we're able to use this somewhere else in our script, which we will do by coming back down to our onInput text entered function. And here, we're actually going to get our response to output to the user from our command processor. So our game script here is still going to be responsible for putting all the pieces together and handling the instancing and freeing of all of our responses, etc. But our command processor is going to be where the logic for our game is determined, or it's going to call into places that do it at least. And the command processor is going to output back to our game what the actual response should be. So what I'm going to say is var response. We can change the name later, but we'll say command processor dot process command. And here, remember, this is where our process command function takes in two parameters, a first word and a second word. So what we could actually do is we can process, we've got to get that first and second word somehow. So there's two options. We can either do that in our onInput text entered here. We can get the first and second word, or we could let our command processor do it itself. And if you think about single responsibility, we want each function and each script, each node to really have one thing it's responsible for. We really don't care or want our game to be responsible for parsing our input. Our command processor should really do that itself. It's the one processing the command. So we're actually going to change the parameters that we use for our command processor here. I just wanted to do this first pass just to kind of show you the thought process that it's good to have as you're making your game. We realized that this interface we had here where we're passing in the words would require our game to do the processing of the command, or at least to parse out the first and second word in our command, which we don't really want to do. We'd rather save that responsibility for our command processor. So in order to do that, we're actually going to change our interface here, and we're just going to say input string. So we're only going to have one parameter. It's going to be the entire input, and process command in our command processor is actually where we're going to do the parsing of that and decide if there's multiple words or only one, if the input is valid, etc. We don't want our game to have to handle it because it's just not its responsibility. It doesn't make sense. Our game isn't the one parsing it, it's our command processor. So in order to do this, all we're going to do is just pass in new text to our process command. Remember that new text is the text that was entered by the player, so we will send that to our command processor, and our command processor will return a response. Now, eventually we'll have to not just output a text response to the player, something in our game is actually going to have to change, like a door will be opened or the player will go to a different room. And we'll handle that in the next few videos when we actually get to implementing it. But for now, it's going to be enough just to start implementing our command processor. So we're going to do that right now. Okay, so one thing we're going to need to do eventually too is actually this response we get back from our command processor, we need to actually output that to the user. So what we're going to do is actually replace the "this is where response would go" default text we had in here with response. So whenever the user enters something, we're going to show them both what they entered, just as a validation or a confirmation, so they can scroll back through the history, which we're already doing, and the new response they've received from our command processor. So now we have everything we need to start implementing our command processor. And just to make sure this is working and to show that our command processor is actually the one putting out our new input or our output that our user is going to receive, we can just do return some output. And now when I run our game and I type something, we should see some output. So I'll type hello, some output. And whatever I type, same thing. So this is a good start. It shows that whatever we do in our command processor this is where our response is going to come from. And we're going to keep all the logic to determine that response nice and separated. It's going to be modular and abstracted away from our game. So our game doesn't have to know how our responses are generated. It just has to know that they're getting generated, and it just has to output them. So just a nice little quick lesson on single responsibility principle and how to modulate your code or make your code a little bit more modular by breaking it up into blocks or nodes that each do their own function. Okay, so let's actually start writing the code that's going to do our command processing here. I feel like I've said that 3 times, but this time it's happening. So the way I envision this, at least a first pass, we can always make it better later if we need to, is that we can just have a match statement, which if you're new to GDScript is like a switch statement in any other language. We can just have a match statement that will kind of match on the first word, and then it'll send, depending on what that first word is, it'll call a specific function, and each of those functions will take the second word as a parameter there. So just as an example of that, what I'm kind of envisioning is, let's just say var first word. Actually, one important function you're going to need to know on a string in GDScript is split, and that's what we're going to use here. So I'm going to say var words equals input.split. And there's a couple parameters that go into split. The first is the delimiter. So this is the character that's going to be split on. Now for our game, the user is going to be typing a space in between words. So like go space west. So our delimiter is going to be a space. And then allow empty is true. We want that to be false because we don't want empty words, you know, if they have a couple extra spaces, we don't want that to be included. So if you do go space, 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 west, we just want it to be go west, not go empty, empty, empty west. And then max split, we'll just have a 0 here for now. We don't need to have a max split. So let's say you only wanted it to split a maximum of 2 times. And then even if there were other spaces later on, it would just be included in one word. We don't really need that. So what this is going to return is an array of words. So we can say var first word. This is going to be words of 0. Now we need to be careful here because some commands probably won't take a second word. Like let's say we add a back command later on. The user doesn't need to say back west. They can just say back to go back to whatever room they were just in. So we're not always going to have a second word, but this first word is going to be really important. So we'll just start with this for now. We can have something here where say like if words dot size, and we can say less than 1 or just equal to 0. So if when we split our words, there's no actual words, it's just one thing, then we can just return an error. For now, we will just say return, we'll just say like error, no words were parsed. And we can edit that later on if we need, but it'll work for now. So we're going to get our first word here, and now we need to switch on this or match on it. So I'm going to say match first word. And the syntax for this is pretty simple. You just say match and then what you're matching on, and then you just have the cases. So let's start with go, because we know we're going to need a go command, right? We want to move between rooms in our game. We're going to eventually have some rooms that the player can move between. Sometimes the door will be locked, sometimes not. Hopefully items, eventually maybe people to talk to, but for sure we're going to need rooms and somewhere to go. So if the first word is go, then I will just type go here as a string, and then you give it a colon here to say, hey, all the code under this block is what we're going to do. I'm going to say go, and we need to actually create this function. So I'll create a function now. Let's say function go, and this is what I meant. We're going to make a specific function for every specific word. And remember, some words are going to require a second word, go being one of them. You can't just go. You have to go west or go east or go north. So I'll say second word, and this is going to be a string, and we'll handle parsing that up above. But so now we see that we are, we're matching on our first word, and we are going and doing. Now, one other thing we need to be careful of is the casing of what the user types. What if they capitalize go? It shouldn't really matter. So what we're going to do is actually use Godot's built-in lowercase function just to turn everything in our game lowercase. So in Godot, the way you do that, it's a function called toLower on a string. So we know that words here is a string, and we're going to do toLower. It doesn't take any parameters, but that's how you do it. And then the return value of this is going to be a lowercase word. So now we can just use everything in lowercase here, and we don't even have to worry about case. So right now we are parsing, and if the word is go, then we are going to call the go function. The problem is that go is taking a second word here, which we don't have. And so what we can do is have a function here, something that will parse that second word or print out an error if there is no second word. Let's do that outside of our match statement so that we can have a little bit better error handling. So I'm going to say var second word, and I'm actually going to set this to be just empty right now. And then what I'm going to do, because we don't want to say words of 1 if there is no second element in our words array, that would throw an error. So I'm going to say if words.size is greater than 1. So if we have at least 2 words, then I'm going to say second word equals words of 1.2 lower. So what we're doing here is saying, hey, second word, we're always going to have second word as a variable. It's just going to be empty. And what that means is that we can pass in second word wherever we need it, even if the user failed to enter a second word. And we'll see that play out right here. So if I add second word to our go command here, what we can do is we can say if second word is empty. So we can just say if second word equals empty. Then we can say we'll be able to return here a response that says, hey, you need to enter a second word. And here it's important to remember that in our game script, we said that our process command function is going to return a string. So we need to write our process command function to do that. And just to make sure that Godot is helping us ensure we're doing that, we can add a return value here that is just string. And so now we'll see we're going to get an error eventually. I've got a couple errors going on right now, but we'll just say return go here. And that means we'll return the value of go, which means this go function needs to also return a string. And we're going to use this pattern for pretty much every command. The name of the command is the function name, the second word is a parameter, and a return value of a string. So in our go command, if we have no second word, we can say something like go where to kind of indicate to the user, hey, you need to include a place to go. Now, if there is a second word, we can just return you go to, and then we can just do %s. I'll explain this in just a second. Second word, or we'll just say you go. Now, what I'm doing here, this %s, it's actually a fragment that goes all the way back to C, I believe might have been the first language to do this, but it's a way of printing strings. So you're including a variable here. So this S stands for string, and % just means variable. So you're saying use a string variable. And in order to actually tell Godot which variable to use, you use this %sign, and then you include the variable there. Now, let's say we wanted to print multiple strings. I could do %s. And we've got a problem because we're saying there's 2 variables here, but I'm only supplying 1 variable here. So if I wanted to interpolate, or if I wanted to add in multiple string variables to a string, I would use an array actually, and say second word, and say some other string. Now, and you can do this indefinitely. So if I had 20 strings, I could just have an array of 20 here. Now, we only have 1, but I just wanted to show that in the future in case you need it, and just to explain what we're doing here, what's going on. So when we use this %s here, we're saying, hey, replace this %s with the variable that we are providing after this % operator here. You can also do things besides a string. So you can do %d, for example, which I believe is a number, or %i. I'm not sure what all the different variables are, or letters you can use in Godot are, but there's plenty of them. So anyway, we've got a go function here, and it is returning either go where to prompt the user to try typing the command again with an actual second word, or it will say, hey, just a confirmation, you go wherever you typed. So things are looking good. The only problem is now we're getting an error from Godot saying, hey, you've got this process command function here, but you're saying the return type is non-void. So because we're saying it returns a string, we always have to return a value. That's this error here. It must return a value in all possible paths. Well, we're returning a value if go is used, but if go is not used, we're not returning anything. And so in Godot, the way you can provide a default case, so for say something is entered that doesn't match any of the specific or explicitly defined cases here, you can have a default case, and here we'll say return, and we'll just say unrecognized command. Please try again. And again, we have plenty of room later on in our game to make this more intuitive, but for now, this is going to be a great way to start building our command processor here. So right now, if the user types go and they don't have a second word, it'll say go where. If they do have a second word, it'll say you go to the place you typed. And if the user tries to type anything else besides go, they're just going to get an error message saying, hey, I didn't recognize that command, try it again. And so we're trying to provide something to the user that will prompt them to type in the correct things that our game will recognize. And you see we've already got a pretty nice command processor here that's going to be really easy to continue building on. And it really didn't require much work at all. I mean, this is 25 lines of code. So really efficient, really easy, simple way to start doing some command processing. Okay, so let's see it in action. If I play our game and I type hello, we should say unrecognized command, which we do. Now if I try typing go, it should say go where. And if I say go east, it should say you go east. Eventually, soon we will have rooms that you can actually go into where you'll be able to output, or you'll be able to see which directions are valid. And so we'll have some better handling there. But for now, we have a command processor that is able to take user commands and do something about it. So this is really cool. And to end this video, we're just going to do one more command to kind of give the user some options so that they're not just left out on their own trying to figure out how to use or play our game. Okay, so towards that end, let's actually add another command where the player can type it to see what commands are available. And we'll just call this help. So function help. And this command is actually not going to take a second word, because when you type help, you don't actually need a second word. So we'll just have this return a string, no parameter here, and we will say return. Okay, and so we're just going to return a simple string here that's going to output to the player what commands they have available to them. So we'll say you can use these commands, and we'll say go, and then we'll say location, and we'll kind of use this bracket notation here to denote a second word is required, and then we'll just comma separate our list here. So this is a very simple list. It's not pulling from like a predefined list in our code. So if we add more commands, we're going to need to hard code them into our string, which, you know, ideally down the road you won't have to do, but we're going to be adding commands pretty infrequently. So I think having a hard coded list here is totally okay, and we can just add to it later on. So the user is always able to type help in order to figure out what commands they have available to them. Now we need to actually add this to our match statement here. So I'm going to type help, and this is just going to return help, no parameter needed. Okay, so we've got the basis here for a really nice command processing system. We have an example of how to do a command that takes a second word, how to do a command that does not. We're handling when the user doesn't properly use a command or anything like that. The one extra thing we can do just to make our game start off a little bit better and give the user some orientation about how to play is give a message to our user when the game starts off that just gives them some information. So what we can do now is actually come to our game script here, and then on ready, we can actually create a new input in a new input instance that we can output just like some starting text to the player, like you are here. Here are the commands available to you. Here's how to play, just to give them a little bit of ways to start the game off. Now, toward that end, we want the way that our game presents information from the game itself to be consistent. It's very important that your user is able to immediately identify what is a command they've previously typed versus what is information the game is giving them just by the font color and size, etc. So we want that to be consistent. So if we go over to our input response scene that we already worked on, we see we've got an input history and a response type. Now, what I want to do for our intro text is use this response type without having an input history, because the user hasn't typed anything yet. It's just the start of the game. So what I'm going to do is right click on a response here, and I'm going to save branches scene to make this its own scene that we can reuse. So I'm just going to call this response, and I'm going to do the same for input history, even though we're not going to reuse that right now, but we might in the future. And the nice thing about this is that we can keep building out response. Like maybe we'll change it to be a rich text label that has a bunch of potential color options or text effects, or it does some formatting, it's multi-line, etc. We're giving ourselves the space to change the internals of this a lot while making the interface that other scripts and nodes use to call into it equally the same. So we're just getting a nice little bit of reusability here. And now from within our game, we're going to actually be able to grab our response and then have one of those. So I'm going to come into our game script here and do the same thing we had before. I'm just going to say const response. This is going to be pretty simple to what we did with our input response. I'm going to scroll down, find response.tscene, and we're just going to use this. When our game starts, I'm going to instance a response variable, and then just add some basic starting text to it. And again, in order to do this, we can kind of refactor a little bit of code we've already written. So if I come down to input text entered, we pretty much want to do the same thing we're doing here, where we're doing history rows.addChild input response. And our input response is going to be a little bit different, but we want to do the same thing. So what I'm actually going to do is pull these out into its own function and say function add response, and we'll just say add response to game. And we'll just say response. And we're not actually going to type this because it could be really anything. Actually, we might just give it a type of control for now because it can be a input response, just a regular response, input history. We're leaving it open-ended so that anything can be added to our history rows. And so what we're going to do, I'm just going to hit Command X on this row to take it out, and then Command V to add it back in. And now we're saying history rows.addChild response. And what we're also going to do is add this delete history beyond limit. So every time we add something to our game, we're also going to delete history if we're hitting our limit. And so now what I can do on our input text entered function here is just say add response to game. And this is just going to be input response. So this is doing the exact same thing as it was before, but we've just pulled out the functionality about how we're actually adding a response to our game and getting rid of extra history to another function, and that means we can reuse this at the beginning of our game. And so now up here, what I can do, remember that we have this response variable here. I'm going to say var starting message, and this is going to be a response.instance. So I'm going to create an instance of our starting message, and then I'm going to say add response to game starting message. And this is going to add our starting message to the game right off the bat, and it's going to handle the internals of where we're actually adding it to our scene tree by default because we pulled this out into its own function. And now we're getting some really nice reuse out of this function across our game script. The only thing we need to do now is actually set the text that's going to appear in our starting message. So in order to set this text, remember that our response here is just a label, and so it's just the text property that we want to access. You can see the name right there, it's just text. So if we come to our game script, I can just do starting message.text, and here I'm just going to hard code a string. Eventually you can make this an export variable, or you could load it in from a JSON file. There's a ton of options you could do, but for now we're just going to hard code it, and I'm just going to write a simple message. The theme for our game is going to be your kind of typical standard fantasy fare, you know, castles and dragons and all that. So if you want to make a sci-fi game or other things, you're totally fine to change that in your own game as we go. But just, I'm going to be doing classic fantasy stuff just so it's easy and recognizable. So I'm just going to type, you find yourself in a house with no memory of how you got there. You need to find your way out. And then I'm also going to add, you can type, and I'll just say help to see your available commands. And so we're going to edit this later on. You know, we can add more or less, but we just want to have a message that appears just to kind of show the player, hey, this is what's going on right at the start of the game. So now that we have this, if I run our game, we will see right at the start, you find yourself in a house with no memory of how you got, I don't know, because it gets cut off. So we got to fix that and make sure that our messages will wrap around to the next line. So in order to do that, we need to come over to our response scene, which I'll just do here. And here, you'll see that if I just start typing a lot, it goes off however long. But we want to hit the auto wrap button here, which is basically going to say whatever width it's given by its parent container, it's just going to use that amount of width. So now when I start our game, now that we have auto wrap enabled, and let's actually make sure this is true for our input history too. So if the user somehow types a massively long message, this will wrap as well, even though we probably don't need it. So now if I try running our game with auto wrap turned on, you'll see that we still have a problem because it's wrapping, but it's only giving one character of width. And the reason for this, again, just some of the things you have to learn over time by working with Godot's control nodes, is that if you look at our container, so our background, our margin container, they're all taking up the full width and height. Same with our rows. Our game info panel is taking up the right height. But our history rows section, where we're actually adding our game info, our responses, doesn't take up anything by default. And that's because the size flags it has for the horizontal and vertical expansion are just set to fill. They don't actually expand, but we want this to take up the max amount of size that our game can. So now if I set this to expand horizontally and vertically, it will take up as much width and height as our game is going to give it. And you'll see it's now taking up the full width and height of our game. And so now if I run it, we will see that our starting message is available and totally readable, and it's wrapping correctly because it's using the amount of width that our history rows section now has. And so if I type a bunch of stuff and just start typing go, you'll see that this continues to be the case and it's still scrolling correctly, and it'll scroll down. If I go to the top and type, we're still scrolling, etc. So everything is still working just as we wanted it to. We still have a scrollable area, but we now have it wrapping correctly, and we've got the start of a command processor. So I hope this has been a super helpful video and that you've learned how to write your own command processor that you can expand and do what you want with. If it has been a helpful video, then leaving it a like and subscribe is helpful to support the channel. We'd love to have you in our Discord server. The link to that is in the description. Ask any questions about the tutorial there. And if you find my work helpful, donating a coffee on Buy Me a Coffee helps me continue to make this text adventure tutorial as good as possible. Thanks so much for watching, everyone. See you in the next video.